Hello and welcome to today's class. My name is Otobo Edward and we are going to be looking at direct current circuits, resistance and resistivity. The objectives of this class are as follows. What is a direct current circuit or DC circuit? Understand the concepts of resistance and resistivity in circuits. Compare resistance and resistivity in circuits. Solve minor problems involving resistance and resistivity in circuits. Now, what is a DC circuit or a direct current circuit? The direct current circuit is a very simple form of circuit or electrical circuit. It is an electrical circuit that consists of constant sources of voltage, current, and resistors. Now, these are simple diagrams of a DC circuit. The diagram to the left is a very basic diagram of a DC circuit. You can see the E, which is 12 volt indicated there. That is the battery source. You will see the small letter I, which is indicating the direction of the current flow in that circuit. Then you can see the arrow, which in this case is 60 ohm, which is representing the resistance of this circuit. Now the diagram to the right is basically the same diagram on the left, but in the case of the right you have the voltmeter, which is the V that is encircled, connected in that circuit. The voltmeter is an instrument used for measuring electrical potential difference between 2 points in an electrical circuit. Now you can also see the A that is encircled, which is the ammeter. The ammeter is used to measure rate of current flow in that direction. And you can also see the arrow, which is the resistance of the circuit. There's something very instructive about the DC circuit, which you should take note of. It is that in a DC circuit, electrons move only in one direction. What is resistance? Resistance is also known as electrical resistance, and it is the measure of the opposition to current flow in an electric circuit. That is to say, in any given DC circuit, there is a degree to resistance of current flow in that circuit. And if that resistance is measured, then that becomes the resistance of the circuit. Resistance is measured in ohms and is usually symbolized by the Greek letter omega. As depicted in the diagram below, the medium A represents less resistance and hence more current flow through the medium. The medium B shows more resistance and hence less current flow through the medium. Resistivity. Resistivity is a measure of the resisting power of a specified material to the flow of an electrical current. It is also referred to as a measure of the resistance of a given size of a specific material to electrical conduction. You can see that resistivity is specific to a material, while resistance is more or less a general resistance of the circuit, which has to do with the voltage and the current. Resistivity has a lot of other things you take into consideration, like the cross-sectional area, the resistance, and also the length of the material in question. Now the formula for resistance and resistivity will further give you a better insight into the relationship between resistance and resistivity. Resistance is commonly symbolized by the letter R. It is the ratio of the voltage applied V to the electric current I that flows through it. As can be seen, the letter R, which is the resistance, is equal to V, the voltage, over I, which is the current. Resistivity, on the other hand, is commonly symbolized by the Greek letter ρ and is equal to the resistance R of a specimen, such as a wire, multiplied by its cross-sectional area and divided by its length, L, as can be seen in the formula below. Now there are a few things you need to know about resistance and resistivity. A few relationships between them. One of them is that the property of a conductor due to which it opposes the flow of current through it, that is resistance. Now for resistivity, it is the resistance of a conductor of unit length and unit area of cross section. The SI unit for resistance is ohm, while the SI unit of resistivity is ohm meter. The resistance of a conductor depends on its length and area of cross section, while the resistivity of a conductor does not depend on its length and cross section. Simply put, resistance is the opposition of current flow in the circuit, while resistivity is the electrical resistance of a conductor of unit cross-sectional area and unit length. Now, given the example above, the DC circuit there has the voltage source of 12 volts and the current 8 amperes. You are expected to calculate the resistance of that circuit. It's simply putting the V over I. The V in this case is 12, the I is 8. By the time you do the calculation, it goes down to 1.5 ohms, which is the resistance of that circuit. Now the question is, what is the value of the resistance of that same circuit if the voltage source is changed from 12 volts to 15 volts? Now, rounding up this class, you're expected to know what a direct current circuit is, or a DC circuit. A DC circuit is simply an electric circuit that consists of constant sources of voltage, current, and resistor. Resistance. What is resistance? Resistance is simply the opposition of current flow in a circuit. Resistivity. Resistivity is the property of the material which defines the resistance of the material, having specific dimensions.